Hello, my name is Jess. I'm an application specialist and a lab manager for a company called Analytical. Jenna. We are a lab instrumentation company originally based out of Vienna, Germany. And today I would like to showcase three devices. Two of them are actually combined. So we have the 5100 first that has now been upgraded to IC preparation. And then we have the PQ9200, which is our newest model as far as OES technology goes.
Okay, so let's talk about the 5100.
Great. So the multi-EA 5100 is first and foremost a modular instrument. It can do carbon, nitrogen, sulfur, chlorine, as well as solids, liquids, and gases. So typically where we would find this instrument is in the petrochemical industry. So what kind of samples would we look for? We're talking crude, gasoline, naphtha, biodiesel, pyrolysis oils, the gambit of organic matrices and what we want to run on this instrument. So some notes about the instrument. So this is a high temperature combustion unit. It goes up to 1100 degrees Celsius and it has a rotatable furnace. So if I wanted to have higher throughput, I can change the configuration to run vertically. Or if I want to have more variety of my sample types and mixed matrices, I can run this instrument horizontal. This is how we transfer our samples. The big items to note is we have an automatic boat drive, and we have a multi-matrix sampler. The multi-matrix sampler can be used for both horizontal configuration and vertical configuration. So you have different sample types. You can also switch them out for liquids and solids configurations, depending on what your samples are.
Okay, so you got something new on top there. I've never seen it before. So can you give us a little more information on this?
Yes. This is our new IC prep system. So the purpose of this is one, to be a more cost-effective solution for customers that are looking to do IC analysis, but maybe already have our combustion furnace system, or alternatively already have an IC system. The way it works is with the system, we're able to do something called pyrohydrolysis. What is pyrohydrolysis? So the basic principle is that we supply our sample into a combustion furnace chamber, right? So we are supplying our sample in, we have argon, we have oxygen coming in. Now, where does the hydrolysis come in? So we are supplying water from the IC prep system above to our combustion tube system. What this allows for us to do is to make sure we have the full conversion of our fluorine products to HF. So we've combusted, we're adding in water, we have this conversion to HF. From there, the samples can be absorbed in a water solution, and it utilizing a cooling unit as well for the transport to a 15 milliliter conical tube, basically. And so this conical tube will fill up with our sample output, and we will then take it and we can measure it on an IC system. We can use an ion selective electrode, or alternatively, we can use molecular absorbance spectroscopy to quantify chlorophore.
So can you capture this after it's done the sulfur analysis and the nitrogen analysis, or this is completely separated?
Great question. This is something that you would upgrade the system to do. So you can switch it back and forth between the typical 5100 configuration with sulfur, nitrogen, fluorine. And then you can say, I want to do fluorine now. So all that's required is you change out your IC cut module, add your fraction collector, and then you add in a separate combustion tube that now allows you to add water to your sample analysis. We have a changeover video actually on YouTube. The changeover times are roughly 10, maybe even less once you get really comfortable with the system. But yeah, that can change to be able to meet the needs of your different samples. Yeah.
So this 5100 is actually what you use for sulfur and nitrogen as well. But there's lots of kind of problems with the maintenance on that. Can you talk a little bit about the maintenance on this instrument?
Oh, yes. Very great question. So to start off, one thing that we have that's different from others is something called a flame sensor. You won't be able to see it with this configuration, but normally, if we open up this panel here, we have a combustion tube, and on it is an optical sensor. And so this optical sensor allows for us to detect the combustion process and optimize it. If our flame grows incredibly quickly, that tells us we need to take our sample out and reduce it at a slower rate. So basically, the system will optimize that introduction. Now, let's say though, you are running something interesting without the use of a flame sensor, and maybe generate soot. So one of the things we have in our system that aid in easier maintenance process is our auto protection valve. So if you look here, it's hard to see on the outside, but Michael can help direct you. This is our auto protection valve. So this component allows for us to, one, protect the rest of our system from any interesting aerosols or particles to the sample. So what happens is we have a nice little heated plate with a filter at the top, and anything that we don't want to make its way through the system get caught on that filter. When you're running in chlorine as well, it also prevents any harmful vapors from making their way back into the system as well. So the way this will work is if we want to do maintenance on it, we could pull out our clamp here, pull out the APV, and then you have instant access to your filters. So we just have 4 screws, 1, 2, 3, 4. You remove those and you're done. You're able to now access that filter.
Okay, before you put that on, now, one of the things we have to do is change the furnace tube every now and then. So can you talk about how that furnace tube is attached?
Yes, I can. Now, first, so to start off, we would do is one, we will unlock our valve that we have in our instrument. So this is our pneumatic valve. This allows for us to get a nice seal to our combustion tube that sits inside of our furnace. So we would place it into the unlocked position. Then from there, we would rotate our furnace vertically. Then we would just have to remove fast connects. Right now, we don't have a combustion tube here. This is just our, our show unit. But we have these things called fast connects. They're called fast, safe, and tight connections. They're basically little black rubber connections that provide a nice seal onto a quartz combustion tube without the need for any additional work or tools to remove. So you would just remove them using your hands, basically. And so what would happen is you would pull your tubing from those fast connects and then pull the combustion tube straight out in a vertical motion.
So you kind of glossed over something I really wanted you to spend a little bit more time on. That little valve that you just talked about. I found that like a very unique feature because it's a diaphragm. It's almost like a little balloon, if you will, that you stick your tube into and you inflate it, and it ensures that you got a good seal. I hadn't really seen that anywhere else. It's a pretty neat feature.
The auto protection valve is also one of my favorite features as well. I think, yes, it is very neat. It serves multiple purposes, but exactly what you're describing. So we now have our gases coming through and we create this suction basically on the combustion tube that allows for us to have a nice seal. Normally, you would have to use tools to access something like this on another instrument. With us, you just flip the switch in the valve, and now you can easily access that filter component that allows for you to make sure everything is up and running as soon as possible.
So it seems like the maintenance on this is kind of simple.
That's the goal. So we also have finger type connection as well. Everything's made to be incredibly easy to access. Replacing your septa, replacing your syringe. It's all meant to be done with really not the use of tools. The items you're going to be touching on the daily, we want to make sure that you can access them and you don't need to worry about where am I keeping all my different screwdrivers or wrenches, etc.
So again, this is a EA5100 and it's meant to do sulfur, nitrogen. It can do what, CHN or C?
It does carbon, nitrogen, sulfur, and chlorine. So we call it the CSNCl device. Really, in refineries, petrochemical world, this is the instrument we go for.
Okay. All right. That's great. Now let's look at the ICP.
Yes. This is our new Q9200. So as you can see, the first thing you'll notice is one, it's very small, right? The bit top space is not significant here. On top of that, we can actually use the tray that sits in the front for even additional space. Maybe you want to do some preparation on the lab bench and you don't have any space nearby. Now you can create a nice bit of space there for you to use. So the real idea here is that it is space saving. It's an important feature we want. On top of that, we have something called the V shuttle torch. So yes, I'm having Mike kind of climb down here to with me. But the V shuttle torch is our fully demountable torch. Thank you. So what do we mean when we say fully demountable? Each of these components can be removed individually. So if I'm going to attach it with the spray chamber still, but if you look, you can see that we have our injector, our inner tube, and our outer tube. So each of these components can be removed individually. So we're going to do this. Spin a spray chamber real quick. There we go. All right. So yes. Normally I would have gloves while working with this, but yes, this is our fully demountable V-shuttle torch. So we can remove each component individually as needed for replacement. Let's say you're running high TDS. You're running samples that are a bit tougher on quartz material. Then what we can do is make a sample. You don't have to replace the entire torch. You just replace one piece at a time. On top of that, admittedly, this is our wooden dummy unit. On the showcase floor in the other room, we actually do have the unit that you can actually kind of fiddle with. But inside of here, you can't really see our plastic compartment, but we have a new generator that allows for us to reduce our argon consumption. So instead of needing to utilize, let's say, 18 liters per minute, which is very typical for overall argon consumption, we can instead get by on 9 liters per minute. So this argon reduction allows for cost savings for our customers as well. And then on top of that, we do have different kits depending on the different sample types as well. This is something that we've been trying to keep consistent, of course, with all our models. If you want to do organic analysis, you want to do HF analysis, you really want to make sure you have a setup that works for you. So we have some new kits that also allow for even lower limits of extraction, if that's of interest as well.
Now, as I recall, there's something kind of special about the Elite, where as far as being able to measure metals that are difficult.
Yes, very good point. So the claim to fame of our 9200 Elite is the resolution. So to start off, we have a resolution of 2 picometers at 200 nanometers. This is currently the highest resolution out there. And so what that means is, let's say you have lines that are extremely close together. So a very famous one in the wastewater world is the arsenic cadmium. Sometimes those peaks, we're seeing a lot of overlap. Difficult to distinguish between those emission lines of interest. But maybe those are the most sensitive lines. So what can we do if they are kind of looking like a blob on our spectrum? What we can actually do with higher resolution is now separate those two lines. That way we can adequately quantify our different peaks. This allows for us to choose our most sensitive lines and opens us up to more wavelength options, which can be beneficial, especially when you're running difficult samples like rare earth elements or any, honestly, iron. Iron is known for having the most emission lines. So if we're running samples that have a possible interference, that high resolution allows for you to still work with your line of interest. And then on top of that, so wavelength range or concentration range wise, we can go from ppb to percent. The reason we can do that is a feature called attenuation. So my old manager used to call it sunglass mode, which I really like. Basically, what we're doing is we're placing a filter on the optics that allows for us to block out excess light that would cause saturation. What does that mean? That means we can increase our working range. So now, instead of having, let's say, just the axial radio, we have axial attenuated and radial attenuated. That allows for us to have a more flexible working range, which means less need to have all those different calibration ranges.
Seems like we need some more time to be able to really get into what we're doing there.
Oh, Joe? Okay.
But thank you for your time. I really appreciate it.
Oh, thank you.
And if they want to know more information about your products, where do they need to go?
So at the Analytical website, of course, and feel free to reach out to me. My name is Jess. I'm on LinkedIn, and you can also reach out to any of our team members, some of our local team members, and one of you that is OOJA, last name HATT. You can find her on LinkedIn, and she would also be happy to answer your questions.
Thank you for your time, Jess. Appreciate it.